Problem 3. What is the final temperature when you mix 125 grams of water with 348 grams of ethanol? The initial temperature of water was 25.2 degrees Celsius, and the initial temperature of ethanol was 65.4 degrees Celsius. The specific heat capacity of water is 4.184 joule per gram per degree Celsius, and the specific heat of ethanol is 2.46 joule per gram per degree Celsius. As we always do, the first step is to summarize the most important information. The most important information includes numbers with units, what we are looking for, and balanced chemical equations if there are chemical reactions in the problem. To find the answer of a heat calculation problem, I recommend you to use a 2-column worksheet. Well, you may wonder, Dr. H, how do you know this problem has 2 different processes and both processes are physical processes? Well, if you recall, from the problem, we have 2 initial temperatures. Then we must have 2 temperature changes. Each temperature change indicates 1 physical process. Since we have 2 different temperature changes, we should have 2 physical processes. Another hint is we have 2 different substances. They may indicate we have at least 2 different processes. Now let's conduct some analysis to see how can we start from what we are given to what we are looking for. Well, since we know the values of CS of both water and ethanol, more likely we need to use the first equation. Then let's write down the first equation. Let's see what parameters we already know the values. Another fact you need to know is the 2 TF values are the same because when we mix 2 different substances, they finally will reach the same temperature. Another fact we also need to know, Q1 equal to negative Q2. Let me briefly explain how do we get this equation. Well, as we know, the initial temperature of water is lower than the initial temperature of ethanol. Therefore, when we mix the two, the water temperature should increase, the ethanol temperature should decrease, and the heat absorbed by water should be equal to the heat released by ethanol. The water absorbs heat, therefore it is positive. The ethanol releases heat, therefore it is negative. A positive number cannot be equal to the negative number, therefore we add a negative in front of Q2. Now we have 3 equations. Theoretically, we can find the answers for 3 parameters, Q1, Q2, and TF. But for this problem, we only need to calculate TF. Now let me show you the work. To get this equation, we can simply plug in the expression of Q1 and the expression of Q2 into this equation. Now I'm going to show you the math. How do we find TF? Well, let me teach you a trick. When you switch a term from one side of the equation to the other side of the equation, all you need to do is to change the sign from negative to positive or from positive to negative.